Namaste everyone and welcome to Lab 6. Here we are going to solve the problems on flow control and loops. Here there are 8 problems. These are fairly simple problems and you will see I have also used very simplistic logic when we are solving this problem, but you try to complicate it. Of course the programming has to be very simple, but you complicate it for the sake of running those the different codes, and then you try it yourself. These codes I will be putting as in the description. Okay, so these are the 8 codes that we are solving. The first one is display n numbers. So you ask for n and display first n numbers. Second is calculate factorial of a number. Third is you print the numbers in reverse order. Then we check if the number is prime or not. Then we find out the sum of the numbers, first n numbers, and take the average. Then we display the first n multiples of the number. Okay. Then we go ahead with the Fibonacci series, and then we display the sum of the digits of the given number. So let's begin. Here is the code 20. So where it is programmed to display the first n numbers. So we take input from n. I have taken n is equal to 10. You can always use input function and it can be user defined. And I have used a very simple for loop for I in range 1 comma n plus 1. We know that the for loop works from start up to end but not end. So that's why here to include n we have given the range as n plus 1 and we are printing. So because n is 10 here, you will get print out as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now how you can improve this? You can improve this in multiple ways. The first thing is you can use, instead of for loop, you can use while loop, right? Use the input function and let your function be user defined, your number be user defined. Okay, so these are two things that you can outrightly improve. We come to program 21, calculate factorial of a number. We know what the factorial is. 3 factorial means 3 into 2 into 1. 5 factorial means 5 into 4 into 3 into 2 into 1 up to 1. N factorial means n factorial is equal to n into n minus 1 into n minus 2 up to 1. So you ask number from the user. Here I have taken directly 5. So here you can use the input function. You store the multiplication as something. So I have stored this as the result. And then I have used simple for loop. Again from n to n plus 1 to ensure that nth number is included. And I am just multiplying. Result is equal to result multiplied by I. And finally I will get the factorial. Now when you are improving this code, please ask for n, let n be user defined. You can also, instead of for loop, you can use while loop. So these two things you can. So next, go to the next code now. This is program 22. Display numbers in the reverse order. So again, here this program is exactly the mirror image of the program 20, where we displayed the number from 1 to n. Now here we want to display from n to 1, right? So again, ask for n. I have taken directly this as n there. This is mirror image. What we were discussing is, this is the mirror image of program 21. Program 20, right? So program 22 is mirror image of program 21. Again, take n is equal to 10. This can be user defined in your case, and then using a simple for loop, we have this displayed from n to 1. Look at the loop range here. It begins with n, and then it goes to minus 1. Okay, from n to 0, and then it goes to minus 1. How you change? First is use the input function. The second is, instead of for loop, use the while loop. Third is, you can combine these two programs, 20 and 22, and there only you ask a user whether you take the input n, and there only you give the decision whether you want to print it forward or backward. So these two programs can be very well combined. Next we come to program 23. Now here we want to check if the number is prime. Now there are 3 ways of checking number is prime. Here we have used only one way. Other 2 ways I will explain, and you try to utilize it when you are coding this problem. The first way is to find out whether the number is divisible, whether number n is divisible till from 2 to n by 2. Because every alternate number is not prime because it is obviously a even number, so it is divisible by 2, so there is no question of this number being prime. So you check from 2 to n plus 1 by 2, right? N plus 1 by 2, n by 2 plus 1. Okay. And the other way to check is, it's a very rote way, you just check from 2 to n minus 1 whether it is divisible by all the numbers up to n minus 1. And the third one we have used here, look at this, what is the logic used here. So take the number, again I have taken random number 11, this can be user defined in your case, and if this number is less than 1 or 1, then that is 1 is not defined as a prime number, right? And less than 1 also doesn't go, the prime numbers are not in the negative territory. So we need number 2 and onwards, and then after checking this, here is, we are defining a simple for function here, for loop here, and we are checking from 2 to square root of n plus 1, right? Square root of n plus 1. Say in case if the number entered is 49, then we will check from 2 to square root of 49 is 7, 7 plus 1 8. So we will check from 2 to 8, and if it is divisible from, non-divisible from 2 to 8, the number is prime number, otherwise it is not a prime number. This is the logic. So for program 23, we have discussed 3 logic. Okay, one is very rote way, check from 2 to n minus 1. Second is check from 2, number 2 to n by 2 plus 1. And third is check from 2 to square root of n plus 1. Okay, of course, you can use the date time function and find out the time required for all these 3 loops to iterate, and which is the quickest way, most efficient way of finding a prime number, right? Next we come to program 24. Now this is to calculate the sum and average of the first n numbers, right? So here this is a quite simple program, take n, and here I have defined as 5. You can always use the input function and make it user defined. Then total sum, here we have just taken the sum here. You can use another function n bracket n plus 1 by 2. This is also good, this also you can use, or you can use for loop to find out the sum. You can use total sum divided by n will give you average. Now don't stop at just sum and numbers and average. You can take multiple numbers and find out the average. You can find out the mean, median, standard deviation. Those things also you can calculate and move on with this program. Always remember, the programs that we take here in the class is the simplest possible programs to explain the concept, but nobody is stopping you from learning more and learning more evolved, right? Next we come to program 25. Here we are going to display the n multiples of a number. So what it means is, here look at this. I have taken a number n. This in your case can be user defined, and I want first 5 multiples of this number 3. Okay, so look at the output. I am getting 3, 6, 9, 12, 15. Again, use the for loop, and you just do this. You number multiply by I. You can do it in a more fascinating way, right? You can take a number. This is something similar to writing tables of 3 or any other number. Table of n. That's what you are writing, right? So both these numbers can be user defined, and when you write here, your output can be 3 1s are 3, 3 2s are 6, 3 3s are 9, so on and so forth. Okay. Other change, you can always use while loop here and try out this, so on and so forth. Okay. Next we come to program 26, displaying the first n numbers of a Fibonacci series. Okay, what is Fibonacci series? Fibonacci series means you begin with 2 numbers, 0 and 1, and the next number is addition of previous 2. So 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, now 2 and 3, 3 plus 2 becomes 5, 5 plus 3 becomes 8, 8 plus 5 13, 13 plus 8 21, and the series goes on. And if you know that if you take the ratio of these successive numbers, then you will stabilize at a number called as golden ratio, 0.618. Okay, Fibonacci series originated from India. If you read the deeper text of mathematics, the Fibonacci series. And anyway, so we go on here, and we want the first 7 numbers of Fibonacci series. Take the series starter, a is equal to 0, b is equal to 1, and look at this. Okay, we are then next number is a plus b, and we then assign b to a, and b is equal to a plus b, and this is how the series will run for first 7 numbers, right? So look at this. To get it in one row, you have to have look at this print statement. Okay, we are printing this statement, and because of this, we are end with here a space. Here we are going to get the output in the same row, not like this in a column. Right here we are going to get the output in a row. You can have a comma here. You can have, you can do a lot of trial error and find out how this function exactly works. Last we come to program 27 to find the sum of digits of the number. So you ask the user defined number. I have taken 1, 2, 3 for the sake of simplicity. And then what we do? We just go ahead and find. First we want to get these numbers 1, 2, and 3 separately. So the logic here used is first we will this number. First we will take the remainder when we divide by 10. So module by 10. So n modulus 10 will give you 3 in this case. And now we want to remove 3 by using the floor division. So n floor division by 10. So this is nothing but n is equal to n floor division by 10. This will remove the last digit. And then we got 12. So we have already received 3. 3 is added to 0. So 0 plus 3 is 3. Then we got 12. Again we get the last digit by this modulus. And then we got 2. 3 plus 2 becomes 5. And we got here 12. And then we take the floor division of 12, floor 1. Then we got 1. And 1 modulus divided by 10. We got the remainder as 1. And 1 floor 10 becomes 0. And then when this becomes 0, this while loop will stop. Now look at this, because the number we are not aware. Therefore, what we have done is we have used while loop here. Typically, we use the while loop when the number of iterations are not very clear, right? So what changes you can do? The one change you can do is that instead of while, try to use for loop. Okay, and have a condition there where you have break condition, use the if statement and break statement there. And this is how you can do this lab 6 from the codes 20 to 27. So again, these are very simple codes explained in such a way that these are very simple programs that I have written. You should not stop at this. Your program should be much bigger, better than what we have discussed here. So thank you very much. Have a great day.